and water. And we have Filippo Newton with us today. Thank you very much, Filippo, for all the work you and your colleagues did reaching out to your ecosystem. And also the Portuguese Water Partnership, who are also in the call. Thank you also very much for your help and reaching out to your network. We know that it's been sent out by associations linked to environmental technologies in Portugal, such as IEPSA, Epimeta, and others. So thank you all very much for the interest shown. We noticed that there was a big interest from the Portuguese associations and agencies to join us. So thank you all very much. We really enjoyed working together with you. And I would like to pass on the word now to Ezra. So welcome, Ezra, and please explain us a bit about the initiative.
Thank you so much, Marion. So I'll just briefly introduce myself. My name is Ezra Shen. I work at the Netherlands Embassy as the Deputy Head of Mission, and I'm also the Head of the Economical Department. And I'm very, very happy to be here. And I'm very happy with the great interest that the webinar caught. I'm very happy with the work that the Chamber of Commerce, Marion and Sherina, together partnering with the Netherlands Water Alliance, Juliette Douglas, have been doing. And I would also like to, as you already did, Marion, I also would like to emphasize our thankfulness to ADEN and the Portuguese Water Partnership. So I just wanted to briefly explain to you how we came about all this and where this webinar is part of. So I joined the embassy around 2.5 years ago, and I was discussing with my colleagues, okay, what will be our priorities for the next year or the next years? And what we all agreed upon with our team, and several team members of me are participating in this webinar, so feel also free to talk to them later on. There is Lisa Ploeg, there is Philippe Fernandez. You will maybe meet them later on in the breakout sessions, but we really thought that water was one of the thematics where we could facilitate cooperation, exchange of knowledge, but also exchange of technologies between the Netherlands and Portugal. As you all know, the Netherlands is known for its water technologies. There's a lot of Dutch companies working on very innovative solutions in terms of water problems, and you touched upon some of them: resource recovery, the water energy nexus, water leakage, but also scientific research. And also for Portugal, it's a very important topic. And we've seen that with the drought and other problems arising, water leakage, that we really were convinced that there was an area that we could facilitate exchange, facilitating networks. So there the idea was born. And we first started with a consultant who did a research, conducted a first study. That was presented actually some months ago in Lisbon, where we had a Dutch delegation coming in and having a visit, and the results of the study were presented. And as a follow-up to that meeting, this idea came up to organize a webinar where we would actually also try to connect different actors from Portugal and the Netherlands. And I'm very happy to see that there's also actors from other countries joining. I mean, our role is to facilitate and to bring Dutch technologies also to other countries. So I really hope that this webinar will help to better understand what do the Dutch have to offer. Maybe that's said very bluntly, but it's actually that's what it's all about. And I wish you all a very pleasant session. And just for you to know that this is part of a roadmap of an agenda that we're working on. So there will be follow-up, and please also everybody feel free to reach out to the embassy if you have any suggestions, any ideas, or if you are looking for something in the Netherlands and you cannot find. We are very happy to facilitate, me and my team. Thanks so much.
Thank you very much, Ezra, for this short introduction. So as said, this webinar is focusing at large water users. And so we have people from municipalities, we have people from research institutes, we have people from the industry. So you can think about architects of swimming pools or hospitals, but also the hotel and industry. We have people from the agricultural part, food and beverage, textile companies. So it's a very wide group of people joining us. And we also have people from municipalities and ministries from both the Netherlands and Portugal. You will meet some of these people in your breakout room after the plenary session. So just to give you an idea about the program, so we have a short welcome now for you to understand what it's all about. We then have pitches of 4 companies, and we do it a bit in the Dutch way, which may be a bit rude for Portuguese standards, but let me explain it to you. So we've talked with all the companies, and we've told them that they have exactly 8 minutes to present what they want to present. So when it's 7 minutes, we will blow the horn. I hope you can see this horn. Well, it's a bit difficult online, but you can hear it all. And so 7 minutes means that the speaker has to rush up and finish his presentation. Even if he can't finish his presentation, we will cut him down. So don't think of that as being rude, because we do understand that not all presentations are useful for everyone. That's why we have the breakout sessions. And most of you have given us already your preference of which breakout session you would like to be in. So that way we wanted to make it as useful as possible for everyone in this call. So after the presentation of 8 minutes, we'll give every participant the opportunity to write in the chat a question if they like, but we'll only have 2 minutes for those questions. So any other questions you may have, you can reach out or afterwards or during the breakout session with that company. So even if your question is not being addressed, don't worry, you can always get back to the speaker later on or in the breakout session. So that is to make it more dynamic, and our experience tells us it works really well. So please don't think of it to be rude. I think someone else is taking over the control of the presentation now. Don't know who that is. But please continue then to the next slide, because after the breakout sessions, this will end. I don't know. Someone has been working with the, I'm sorry about that.
I cannot see the presentation anymore, Marion. I don't know if anyone can see it at all, but...
No, someone took over the control, and I don't know who that was.
So you have to put it up again.
Yeah.
The calm before the storm.
Is it? This is not very handy. Okay.
So shall I give a brief introduction about the companies? In the meantime, you're doing the PowerPoint, Marion. So
Yes,
the first company who will pitch is Hydraloop, Klaas Pol. Hydraloop is a winner of many awards since this technology came onto the market. I'm not sure when it was, but I think in 2000, in 2015 it came onto the market, and its specialism is in water reuse, especially in building environment, but also your own house. That's the first pitch. Is that correctly, Klaas?
Yeah, perfect.
Thank you. The next pitch will be done by Joost. Joost is from VDH Water Technology. And this is a real energy saver because it works with low temperature, and it's specialized in the beverage, crop industry, agriculture, beer. Yeah, mostly of that. Is that correct, Joost?
Yeah, we also do quite a lot in pool and potable water.
Yes, exactly.
Yep.
The third is Tom van Remmen UV Technology. One of the most sustainable companies in UV disinfection systems, also in active in the building, recreation, agriculture, breweries. Is that correct, Tom, what I say now?
Yeah, thank you very much.
Thank you. And last but not least is NX Filtration, Ignacio. Also a breakthrough technology because it's specialized in nano membrane technology for water treatment and filtering. And this is one of the companies that is since 2021 on the stock market.
Correct. That is correct.
Nice.
Okay, that's just a little introduction for the speakers, and I'd like to give the word back to Marion again.
Yes, so I would like to ask everybody not to touch the presentation. I would like to just present you the moderators, which is Juliette. Thank you for stepping in, Juliette. Hein Molenkamp, also from Water Alliance. Thank you very much for joining, Hein. I would ask everybody also to mute their microphones, please. Then we have Philippa. I already introduced her to you from Aden, and myself. So we will be doing the 4 breakouts. And I would like to ask the first speaker, Klaas, Paul from Hydraloop, to come into the session and to start your presentation. So your 8 minutes will actually start as soon as you start talking, Klaas.
So I should take control of the presentation right now?
No, I will do it for you.
You will skip the slides? All right.
Yes.
Well, hi everyone. Good afternoon for the people in the Netherlands. Good morning for the people in Portugal. I'm Klaas Pol, work for Hydraloop, and I'm going to tell you something about grey water recycling and what this could mean for smart cities and buildings. Next slide, please. Yeah, there's a global challenge that we are facing, and well, if you follow the news a little bit, you see and you hear that there's emerging water stress. It becomes more and more dry all over the world. And actually the only way we get new fresh water is because of rain, snow that melts. But the world population is growing, and the fact that more people come into the world does not mean that it starts to rain more. I think there's another animation in this slide. Yeah. Because if we zoom in on Portugal, we can see that this water scarcity problem is also there in Portugal. It's present in Portugal as well. Of course, this is a big problem, but for companies like ours who think we have a solution for this problem, it's also a global market opportunity. Next slide, please. Yeah, this is actually our slogan. This is what we always say: act wise, use water twice. Because we say every home, but also a lot of buildings have their own source of lightly contaminated water, grey water, which you can easily reuse for a second purpose. Next slide, please. Yeah. This is how it could look in a house or in a building. So what do? You can see the Hydraloop in the center of the picture. We collect all the lightly contaminated grey water in a building. We treat it with our Hydraloop so it can be reused for non-potable uses like toilet flushing or washing machine or garden irrigation. You don't need drinking water quality for that. Next slide, please. So the treatment process, how does it work? Well, very quickly, it's a combination of 6 different treatment steps. They already existed for a long time. Only what makes the Hydraloop so special is that they are combined in our device. So we apply sedimentation, flotation, dissolved air flotation, foam fractionation. Step 5 is a bioreactor. And the last step of our treatment process is disinfection. And we do not do this with membranes or with chemicals. We do this with a UV light. Next slide, please. Well, our Hydraloop treated water quality meets all the international stringent quality standards that are there for grey water recycling systems. I would like to highlight two. One is the NSF ANSI 350 certificate. It enables us to sell our solution, for example, on the market of the United States. What is also relevant to mention is that Hydraloop meets the new European standard that is there for grey water recycling systems. It was launched or presented last year. Next slide, please. Our product portfolio. So we started with the Hydraloop H300, which you can see on the left. Soon turned out that people from the US have need double the amount of water that we need in Europe. So we started working on a larger unit as well. It's the Hydraloop H600. Next slide, please. A Hydraloop cascade. This is very interesting. For example, you can see an example project in the bottom of the screen. This is a cascade installation where we will treat collectively all the grey water from 300 different student houses. We will collectively treat it with a Hydraloop cascade. And what is a Hydraloop cascade actually? It is multiple devices put next to each other. So they can help each other in their way of treating. And with way less amount of units, you can treat a lot of water. So this is very interesting for hotels, for student housing, for office buildings, sports clubs, airports, etc. This is a new product solution that we worked on for months, years actually. And this is the Hydraloop Concealed, because not everywhere you have a lot of space available. So with this Hydraloop Concealed, actually the device is integrated into the wall, which means you will save a lot of space. And we launched this in January this year at the CES, where we also won an innovation award in the category Smart Home. Next slide, please. Well, some pictures of happy customers we have all over the world. I think we have shipped our devices now to 35 countries all over the world. And this is some nice example pictures. You can see sports clubs, hotels, but also individual households. Yeah, at Hydraloop, we are very proud of what we do, of course, but also of the fact that we get some recognition by international acknowledged entities, like, for example, the WIPO. You can see the WIPO in the screen. It's the World Intellectual Property Organization. It's actually part of the United Nations. Last year, we won a prize for having the best intellectual property. So very proud of this, of course. Next slide, please. Yeah, if you have a phone with you right now and you would like to already receive some information about the project, you can scan this QR code now with your phone and you can share some information about your project with us. And based on the information you share, we can decide, okay, you need this amount of units or you need that amount of units. And we can support you, of course, also with help of our local Portuguese partners to make your project to a great success. Maybe good to mention that with the Hydraloop technology, you can save up to 45% on your tap water supply. I think I have more than a minute left because I didn't hear anything.
Well done, Klaas. Thank you very much. Are there any questions for so far? João, can I give you?
Hello, good morning.
Hey.
Excellent presentation. João Simão Pires from the Portuguese Water Partnership. Excellent presentation, Klaas. I know that you already have local representation here in Portugal through Environmental Waves and Emmanuel Santos Silva.
Yeah.
I was looking at your presentation just out of in terms of a range or order of magnitude. At what price are you placing, let's say, an Hydraloop 300 on the market? What's the price range?
For a household, a typical
Yes.
European household, because I mentioned that the volumes of use differ a bit per country, you should think about 4,000 euros, and then you have it installed in your home.
Okay,
Of course,
thank you very much.
this is a little bit depending on the pipe work, because the Hydraloop is a grey water recycling system, so we recycle grey water and we don't recycle the black water. So you need to separate your pipe work as well, and this is something you should take care of, for example, with help of your plumber.
Of course, got it. Thank you very much.
Thank you, João. Jacques Boutron, you have a question?
Yes, hello, this is Jad from Agri Group. We're an ESCO based in Portugal and Dubai. So my question is, in your product is for solutions that are new build or retrofits? Because, you know, grey water, if you have already a house or a hotel, whatever, you need to do a lot of piping works to collect the grey water. So
sometimes yes, it depends a little bit on the situation. This week we commissioned a cascade of 2 Hydraloop 8600 units in a hotel in France, and this is an existing situation. We did the same last month in Belgium, also an existing situation, and in both situations now 20,000 liters per month is recycled. And this is an existing situation. So yes, of course, sometimes it can be a little bit more tough, but it's always possible.
Okay, thank you.
Okay, and then the last question is from Martin.
Yeah, good morning, Martin. I'm the area general manager for IAG in Portugal. Obviously, we run hotels, so you answered a couple of my questions already earlier, where I can see obviously you retrofit hotels. Yeah, hotels. Obviously, we operate usually with a 4-pipe system on AC units, but then obviously we have fresh water and everything else.
Yeah,
that's a concern. If let's say you mentioned that we have to retrofit the entire building in terms of piping to handle the Hydraloop system.
Yeah.
To what extent does that need to happen?
Well, it completely depends on how your building is built, of course. But the most important thing is that you need to separate the grey water from the black water. And I did not mention it yet, but of course we can support you in this with help of some documentation. What is relevant to mention is that I always mention this example project that we had in Amsterdam, where a hotel came to us and said they wanted to treat 17,000 liters of grey water, so 17 cubic meters of grey water per day, which is quite a lot. And we asked them, what do you want to do with your treated grey water after it's being recycled? Well, we want to flush toilets. So our question then was, how much water do you expect you need for your toilet flushing? Which was just 5,000 liters, so 5 cubic meters. So it's very important then that you dimension your amount of units for that specific project, not on the incoming amount of grey water, but on the amount of grey water or treated and reusable water that you need for subsequent purposes. And why do I mention this? Because it could mean that you then do not have to connect all the different bathrooms to the Hydraloop cascade, because maybe half of the hotel would be sufficient to feed all the toilets, etc.
Yeah, because obviously you have high-rise buildings, you have historic buildings. There can be different. There are different infrastructures in every building. Yeah. And you said, let's say in general, water, let's say potable water consumption savings are up to 20-30%.
No, 45.
45%.
Yeah.
Fantastic. We'll be in touch.
Thanks.
You're welcome.
But was this the 7 minutes? No, right? Okay.
Thank you so much, Klaas.
Thank you.
I think everything is clear. Maybe just the last throw out, the definition of grey water. So maybe for some.
Yeah. Grey water, and you could see it in the schematic overview that was the third slide or so. Grey water is sometimes confused with rainwater, but the rainwater is rainwater and grey water is grey water. So grey water is shower, bath, washing machine, sometimes the sink. So that's important to mention.
Okay, thank you very much. I would like to give the stage to Joost Edens from VDH Water Technology.
Thank you very much. Thank you for the opportunity to present the company and our solutions. And also a special thanks to our colleagues from the Iberia, Miguel Marklev. He's also in the call today. I will explain that relation further on. So if we can go to our first slide, please. Yeah. VDH Water Technology, we are a company specialized in sustainable water disinfection. If we can go to the slide after. So we treat water, and what is it that we achieve by this treatment? First of all, we improve the water quality itself. We make the water safer because we are removing pathogens from that. But as a very important additional, we also improve the quality in terms of unwanted byproducts. So that leads to a possibility to save on the intake of fresh water to compensate for the dirty water that you otherwise would discharge, and hence also the energy that can be related to the intake of fresh water for example, warming that up. And as a bonus, because we do it as we do it, which I'll explain, we improve the labor conditions on site, we improve the carbon dioxide footprint, and the safety all around the water treatment itself. If you can go to the next slide, please. So we disinfect the water by producing locally chlorine. So it's an in situ generation of chlorine. Chlorine is so far in the world the most used disinfectant. It's relatively cheap. In Europe is relatively easily available, but it comes with some downsides. You have to handle it, you have to store it, it loses its activity the longer that you store it, and you don't have control of what goes into the water because whatever you have in the canister or tank goes into the water. Now we take the three principles how to get chlorine, being the salt, the crystals, some water and power. And we do this on site. And because we do this on site, we improve the safety of the disinfectant as generated, the handling of it, which is then absent, and all the consequential items that come with that. But we also reduce these undesired byproducts. Our systems that we have are set up in such a way that we give you full control of what you do want to do with the basics that come from the salt, being the chlorine, the chloride, and the sodium. I will go a little bit more in detail in that now, in the next slide. There we go. Why it is that we give you that control. So there are the main two issues with using the chlorine in water is that, first of all, to reach an effective disinfection, you need to be within a certain pH range. This has to do with the different forms of chlorine, which I will not go into, but ideally you would want to be between a pH of 6 and 7. So the more that you recycle the water that you are using with industrial bleach, the pH level is rising. So in order to compensate for that, you would need to use a form of acid, sulfuric acid or anything like that, to reduce that pH again back to its desired level of between 6 and 7. So in another way, you are using one chemical to treat your water, and you're using another chemical to compensate for whatever that chemical does to your water. That all increases also the conductivity and the salinity in the water that you are recycling. By using a local generated pure chlorine solution, that effect is eliminated. Actually, the chlorine gas itself is slightly acidic. So if you take in a water of pH 7, 6.5, you can recycle it many more times without that salinity being increased further up. So it means that for any process that you have, like for example in a pool, where you would want to save as much water as possible for water saving, for energy issues, you can use the same water many more times as what you would do when you use conventional disinfection. Another item which is quite important, and the main issue with chlorine, is another undesired byproduct, which is chlorate. It's a little bit small letters here, I can see, but chlorate is in fact an oxidation product of chlorine, and it is not allowed anymore in the EU to use this. In fact, many food industries want to have a very low level of that because of EU regulation or because their clients ask it from them. If you use conventional industrial bleach chlorine, then there is already a lot of chloride in it because of the storage that you have. If you produce it in situ and directly use it as per your factory requires it, you are slashing down that value gigantically. Our systems either are 1/5 or 1/50th of the chlorate that comes with industrial bleach. So it's a massive step forward. Okay. Can we go to the next slide, please? Yeah. So in many applications, we have the experience, and we see a major shift in the potable water industry to reduce the salinity, to improve the chlorate level, but still using chlorine as a reliable disinfectant. So we are building for many larger European cities, but also smaller throughout the world. We are building disinfection systems. In food and beverage, we have a vast customer installed base to flush tanks, to clean pipes, to clean the bottling, to lubricate, transport tires, etc., etc.
1 minute more.
Yep. Our main market is the pool market. Here we do also a lot of activity in. If we can go to the next slide. We work with 4 types of products. We have extensive programs and maintenance packs are available. There is over 40 years experience, and we are quite active over the world. Next slide, please. We don't do it alone. We have a good partner in Portugal and in Spain in the form of Prominent Iberia. You see here some experience from us together with the team starting up a machine. And then the very last slide are the contact details of VDH, how to reach us. Thank you very much.
Thank you so much, Joost. Are there any questions from the public? And if not, maybe you have some details questions about the technology and where to use. Can you give a last throw out, Joost, where if you, for example, have a recreation area with a lot of pools, how many more or less water can you save by this technology? You mean you could use the water a couple of times, but are there any figures and facts about this?
Yeah, very important is the corrosion that is affected by chlorine. If we take our purest form that we make, there is a major step forward. It depends a bit on how much evaporation you have also had, which is different from each system. but there's easily a factor 1.5 to 2 is achievable.
Okay, thank you so much. Jad, you have a question, the last one, because then we have to go to the next.
Yeah, it's a quick question. Have you ever disinfected water for like steam boilers or boiler systems in industrial systems?
Boiler water treatment is something that we have been looking at. We are familiar with it, but it really depends on the type of steam that you need. Yeah? If you need super saturated or normal saturated steam. Mm-hmm. So I propose that we link and we discuss it further outside of this.
Sure, for sure. Thank you.
Okay. Thank you very much, Joost. And then I would like to give the stage to Tom and your colleague from Remmen, from Remmen UV Technology. Please, Tom.
Yeah, hello. Good morning or good afternoon. Thank you very much for the opportunity presenting our company. We are in this business for over 20 years, focusing on UV disinfection and UV since 10 years also on oxidation. We are focusing on the European market, and our DNA is on sustainability, knowledge, and reliability. Next slide, please. And we see, next slide, please. We see around the world, and it was already mentioned also in the Hydraloop, that there is a lot of drought, water is getting scarce, but also that the water quality is getting under pressure, and that we are polluting and diluting our water with all kinds of chemicals, medicines, pesticides, and others. So it's not safe and ready for drinking water as such. Beside the chemical pollution, of course, we have these Legionella problems, but also MBR, the micro-resistant organism, that are going to be facing. And we believe, next slide, please. We believe that with proper water treatment, and not only UV, but in combination with other technologies, we can create clean water for everybody. And we believe also that there is an interesting proposition for UV as a non-chemical and reliable technology. Next, please. Like I said in the introduction, we apply UV for disinfection. And you see that contaminated water is going from the right to the left, and it is disinfected, or we use it for Advanox and advanced oxidation. And there we are adding UV light and hydrogen peroxide to make a very strong oxidant to remove all kinds of micropollutants. In the table you can see that there is, for disinfection, a dose of like 200, 600 joules, and for oxidation a lot higher. Next slide, please. For disinfection, especially for the Legionella market, but for drinking water applications, we have a system based on the European standard for drinking water, which is validated, and with a new controller we have continuously control on the reduction of Legionella, where we are controlling the lamp hours, temperature, flow, everything on a real-time basis that people can have a look at. Next slide, please. This is a typical installation and the components that are used to have this control. So you can see from distance whether your system is working and your water supply is safe. And by this, we hope to give people a better insight of what UV is doing and how reliable it can work as such. Next slide gives an overview of a number of systems at different capacities, which can be mounted in after the water meter at the incoming water to treat the water in a reliable way. Next slide, please. We are in a little bit in a hurry maybe, but I try to be ready before the 8 minutes. This is on the AOP, so this is also disinfection, but here we are focusing on the removal of chemical compounds that are not broken down by organic, so medicines and pesticides, but also chemicals from the industry in groundwater, for instance, or in rivers. We are here focusing on reusing water in a second time, so that water can be used again and again. The process is applying these radicals, which are very oxidative, except from fluor. They can therefore break down a lot of components effectively. So it is a very good last step in the activity of your water treatment. Next slide, please. These are some examples of products that we have designed for this technology, and we have optimized them to a very high level so that they are competitive with other technologies which are focusing on removing these pharmaceuticals, and we are oxidizing them and not separating them. And the footprint is very small compared to activated carbon or ozone, and the big benefit is there's no bromate formation, so byproduct formation is not there, or not found. It is not selective, so it is active on all kinds of micropollutants, and besides the disinfection and besides the oxidation and photolysis, it's also a disinfectant. Next slide, please. Here are some examples of this technology. One is in groundwater, one is in hospital water, where we are removing medicines, but also contrast agents. Drinking water, we see that due to not having proper wastewater treatment, drinking water has been polluted more and more. And the left bottom is on a wastewater treatment plant where we treat the water as a fourth step so that it can be reused for irrigation purposes. Next slide. Well, this is the end, I think. Oh, I'm having a lot of time over.
No, I don't think so, but I think the horn doesn't bleep anymore, Marion.
No, it's fine because we noticed it's the last slide. So
okay.
You kept it well within the 8 minutes, Ton. Thank you very much.
Yeah, you can give me 20 minutes or half an hour or a full day to explain about the technology and the advantage and the contribution to create clean and fresh water. That's
but unfortunately, Ton, we don't have that at the moment. I have one question for you. That's from Jad.
Yeah, so my question is about the UV light. How often? What's its lifetime, and how often it needs to be changed?
Good question, Tom.
Yeah, the lamps we are using low pressure UV, which have a lifetime of 8,000, 9,000 to 16,000 hours, which means by continuous use, 1 or 2 years operation before replacement of the lamps.
And just a follow-up question. So this is the theoretical or by practice?
No, by practice. Yeah, this is of course there is a bit of a spread in life, but it can be a little bit longer, can be a little bit or shorter, but that is a practice number. Yeah.
Thank you.
Thank you. And then we have the last question by Arjun. What micropollutants in the TRC are removed and what levels?
And the level of removal can be up to 99.9%, but in most cases, removal of 70 or 80% is applied. It depends a little bit on legislation or on the application where to use the water for in a second time. But yeah, there is different equipment for different levels of removal.
Is that the answer?
Can I ask just one last question, Juliette?
Yes.
Yesterday on the news, Tom, there was some alarming news about the Tagus River being heavily polluted. Probably a lot of it comes also via Spanish industries. And this water is being used for drinking water, and it's heavily affected. So my question is, we have people also from the Water Board of Portugal in the call. Is your technology, could that be relevant for this type of problem?
Yeah, I think so. The UV as a technology in general is applying photons, so it's not applying anything. So it's energy, and it's not selective, and there is no microbiological resistance to it. So in that respect, it is a very safe and reliable barrier for microorganisms in all kind of water treatment plants. And yeah, we know that drinking water is safe to drink, but yeah, there is also with the supply of drinking water a supply of microorganisms, and yeah, so put a UV in between is a very safe barrier.
Thank you very much, Ton. We will try to put you in touch with APAL, I think. So thank you very much for this comment.
Also, Marion, as an addition to this, because we are at the Water Alliance, we represent over 200 companies working all in water technology. We could also have a chat out of this webinar about this challenge in Portugal. Thank you. And then last but not least, I would like to give the stage to Ignacio from NX Filtration. Thank you so much.
Thank you, Juliette, and good morning, everybody. We have 8 minutes, which is a lot, the things that I've done in 8 minutes. But anyway, here we start. Today I'm here to talk about NX Filtration, which is a hollow fiber nanofiltration membrane manufacturer, which are used to produce pure and affordable water for all. Next slide, please. On the left side, we can see how the entire system would look. And here I like to point out that our scope of supply is only for the membrane module itself, which would need to be integrated into a system by an OEM or an integrator with their pump, controller, and valve, etc. To the right, we can see a cross-section of the module with thousands of fibers. And even further to the right, we can zoom into a single fiber to see the internal layer by layer nanocoating of the membrane, which gives this direct nanofiltration properties. Next slide, please. At NX, we offer 2 types of nanofiltration membranes with distinct separation characteristics. We have the DNF80, which is a more open membrane with 800 Dalton molecular weight cutoff, and the DNF40 with a 400 Dalton molecular weight cutoff. Both can remove high loads of TSS, bacteria, virus, micropollutants, And the DNF40 can also reject selective salts, partial softening, and contaminants of emerging concern as pharmaceuticals, PFAS, etc. So depending on the application, we would recommend one or the other. In both cases, the properties of the membrane make it a single-step process without pretreatments or use of chemicals, which translates into increasing the energy efficiency. Our key markets include potable water production from ground or surface water, and municipal and industrial wastewater reuse. We skipped to the first slide, that's okay. Sustainability is at the core of NX filtration. Our membranes rely on 3 pillars for their production and application. We talk about a green chemistry related to our production, as our coating is applied by a water-based chemistry in contrast to conventional solvent-based coating processes. Also, our production spinning line is highly energy efficient thanks to our unique inline polymer mixing concept. When we talk about energy efficiency, we refer to the application of the membrane in operation, as it requires less energy and therefore also realize a significant CO2 footprint reduction. The avoidance of chemicals, it is because with this direct nanofiltration, we avoid the use of flocculants and coagulants in the pretreatment, and also the membranes require a low cleaning frequency thanks to cross-flow operation. Next slide, please. This direct nanofiltration is a innovative and a patented technology, which can be defined as sustainable, low cost, and a small footprint solution. It is, as I said, normally used for drinking water production and wastewater treatment for the reuse of treated wastewater in the municipal sector, where we can also consider gray water recycling systems for hotels, commercial centers, residential areas, as it was addressed before in other presentations about gray water. For industrial applications, it can also be used to optimize feed water quality, and it also enables the reuse of processed water and wastewater, and finally also valuable materials recovery. I can see Marja is putting some pressure on me, changing the slides. But next slide, please. Here we can see the difference between traditional nanofiltration, which is a spiral wound membrane, and the NX filtration hollow fiber DNF. This translates into a quality requirement benefits for DNF. For example, the turbidity limit for traditional nanofiltration at the inlet is 0.5 NTUs, while for DNF is 150 NTUs. So we can spare a lot of pre-treatment. The DNF can also tolerate TSS up to 300 ppm, more COD. It has higher recovery rates, and it can operate also at a higher flux. So all this together means that we can spare significant pretreatment processes with the subsequent energy and chemical savings. Next slide, please. Thanks. In this figure, we can see where DNF fits in replacement of traditional technologies, all in one single step. In cases of either wastewater reuse or drinking water with low fouling feed water, you can replace the typical combination of UF and a spiral wound membrane. And for high fouling waters, it will replace also the coagulation and flocculation process, which is normally combined with UF and spiral wound. So in both cases, it is a single-step solution, which brings energy efficiency, and it is a chemical-free process. Next slide, please. This would just be another way, a more simple way to visualize it. Of course, not always you will need all these technologies, but many times it would be a combination of 2 or 3 of these technologies that could be replaced by DNF, which would only require a 150 micron strainer. Next slide, please. Very quickly, a summary of NX Filtration's DNF unique features. We say it's a simple process, single stage, low footprint, one-step solution. Then also low OPEX with a total cost of ownership between 0.2 and 0.3 euros per cubic meter. It has an average of 70% energy savings compared to UF and RO, and also chemical free. It presents high organic retention and high salt passages, which gives this unique separation characteristics. And finally, the fouling resistant property thanks to the chlorine tolerance, and it is possible to perform backwash. Next slide, please. And I finish with this, just if we have 1 minute left. I wanted to present the pilot fleet. This is our Mexplorer, which is a lab scale pilot just for a proof of concept. And if it's successful, next slide, please, we would lead to an industrial scale pilot for further testing, where we get more information for a more accurate proposal together with our projection tool. And that is it. Next slide. Thank you very much, everybody, for your attention. And I think I nailed it. 8 minutes. Well,
yeah, you did perfectly, Ignacio. Thank you very much, Ignacio. Are there any questions from the public? Because if not, then I have a question. Oh, sorry, yes, Jad?
Yeah, I have 2 questions. I want to ask if you had a use case where we find the comparison between a conventional system and your system. And the second question is, any idea about how much, because you're talking about energy saving in electricity, but how much you save in water? Because in RO system, you have rejection of minimum of 50% or 60% water reject. In your system, what are these figures?
Yeah, well,
thank you.
Thank you very much for the question, Jack. We can dig into further discussion later, but it actually depends on the water quality, just as much as in RO, where you can have 80 or 90% recovery with low salinity waters, and down to 50 you're treating seawater. So also the membrane typical ranges around 75, 80% recovery. So it does have rejection, the membrane, right? But it will depend on the inlet water quality. And in terms of, well, energy savings, I think I said it, and it's clear. It's just an average. It depends on what are you comparing it. One of the applications would be where you can replace it for UF and RO, because many times probably the RO will be just too much for the quality required, where you can actually use DNF. DNF will not replace the UF itself or the RO itself if you have high salinity water. But in many cases where you use this combination, you can actually use the DNF, which has a higher organic matter rejection, more tolerance. So the key is to save all these pretreatment, and it can actually also be used as pretreatment for an RO, and the RO will be much more protected. It will have a higher recovery rate. It will have a longer lifespan, the membrane. So in general, it depends on the application.
Thank you.
Thank you so much. Thank you so much, Ignacio. I think these were our 4 presentation of Dutch technologies. And I think it's time now to go into our breakout rooms and discuss a little bit further about this technology and the challenges we have to go through in Southern Europe.
Okay, so I will assign now the people to their breakout rooms. Let me just tell that we will not come back. So maybe we can thank already all the speakers, and I will put you in your breakout rooms.